In this video, I'm going to show you how to use an inexpensive power relay and basic tools to create a 3D printer safety circuit. This safety system will cut all power to your printer should any part fail in an unsafe way. By the end of this video, you're going to have all the information you need to build this system yourself. Best of all, like all my videos, there's nothing to pay for other than the components you'll need for the system itself. Everything I provide is free. Why do you need this system? If you ever leave your printer unattended for any length of time, which let's face it, we all do now and again, then there's always the possibility that something could go wrong when you're not around to turn it off. Now, I'm not saying that any particular part failure will cause a fire. However, there are some components inside your printer that, if they fail in a certain way, can cause a condition called thermal runaway. Now, I won't go into too much detail of all the scenarios that can cause thermal runaway, but the basics of what thermal runaway is when something heats up to extremely high temperatures and can't stop. A lot of 3D printers have software that try to keep a lid on thermal runaway, but unfortunately, unless they actually kill the power to the 3D printer, they're not 100% reliable. So now we know that we want to disconnect the power when something goes wrong, we need to decide how we're going to do it. What I've done with my printer is used a power relay. What is a relay? A relay, in very basic terms, is a switch that, instead of being actuated by your finger, is actuated by another circuit. In our case, we're going to use a very safe low voltage circuit to do this job, so that at no point are we messing with mains voltage. The power relay that we're going to use is this one that I've linked in the description. This relay gives you two power sockets that are dead until you supply power to this separate plug, one socket that is live until you supply power to this plug, in which case it then goes dead, and one socket that is always live. Therefore, we can plug a couple of devices into the first two sockets that will have the power cut to them if we stop supplying power to this secondary circuit. Now, I have to say at this point that this particular power relay only works with voltages up to 120 volts AC. That means that if you live anywhere that uses a higher mains voltage, like we have here in the UK, you won't be able to use this power relay. I'm currently running through a power inverter, which is reducing my mains voltage down to 110 volts so that I can do this video. I am, however, working on a 240 volt power relay that will enable us to use higher voltages. I will, of course, release a video for that shortly. Make sure you subscribe and hit the notification bell so that you don't miss out on that one. So now we know the basics of how the relay works, we need to decide how we're going to turn it on. The secondary circuit needs to supply voltages of between 3 and 48 volt DC or 12 and 120 volts AC. To keep it nice and simple, I'm going to use a phone charger and a USB lead. All we need to do with the USB lead is cut the end off and find the red and black wires. These are the power wires and will give us 5 volts DC. As you can see here, if you wire these two wires directly up to the plug on the side of the power relay, the relay now has everything it needs to actuate and supply power to the sockets. The green light here shows that the relay is activated. All you need to do is remove this voltage by unplugging the plug to kill the power. Likewise, if we just break the connection to one of the wires, we do the same thing. We remove the 5 volt feed, we therefore deactivate these two sockets, and therefore our 3D printer. So what we need is something that will open this 5 volt circuit when any particular part of our 3D printer gets too hot. For this job, we're going to use a thermal fuse. Thermal fuses are much like a normal fuse, but instead of blowing when too much current flows through them, they blow when a certain temperature is exceeded. Thermal fuses are available from approximately 60 degrees C to 240 degrees C. That's about 140 degrees Fahrenheit to 460. We can use different temperature thermal fuses in different parts of our printer depending on how hot we want to allow that part to get. We'll get into the different temperatures to use in different areas later, but for now I just want you to understand the circuit. Here's a wiring diagram of our system to show how it works. On the left hand side we have the AC or mains wiring circuit. This is all taken care of by the power relay and the mains cables. Our power relay is in the middle. For simplicity, we're only showing one circuit or socket being opened and closed. On the right we have our 5 volt circuit. This is the circuit we have to create. As you can see, we have a 5 volt power supply. This is our USB cable and phone charger. We have a switch and a thermal fuse. The switch isn't 100% necessary if you just want to use the printer's normal power switch, but it helps to show how the circuit works here, and I used one in my circuit. I've created this circuit on the bench so you can see how this 5 volt circuit works in conjunction with the power relay. If we close our switch, the current flows through our circuit and gives 5 volts to the relay. The relay closes and gives power to our mains power circuit. If either the switch is open or we heat our thermal fuse up beyond its limit, then the 5 volt circuit is opened and current no longer flows through this circuit, and then in turn the relay opens the main circuit. This is basically all there is to this circuit. All we're going to do now is add more thermal fuses in series that will be placed around our printer and a standard blade fuse to protect the circuit from an electrical short. So hopefully we all now understand the electrical circuit. What we need to do now is create a way of connecting our thermal fuses whilst protecting them from shorting out on any part of our printer. Now, one thing we can't do is use solder joints and heat shrink. Unfortunately, the heat from both of these would cause the thermal fuse to blow. Instead, we're going to have to use crimp terminals and sleeving that will protect the fuse from touching any other metal parts. I also use these JST connectors, which are linked down in the description, along with the crimp terminals. First, crimp the connectors onto the wires from the plug and use heat shrink on these before the thermal fuse gets involved. Electrical crimp pliers are best, but you can use other types of pliers if you don't have any. Just make sure the wires can't be pulled out. Then crimp one connector to one side of the thermal fuse. It doesn't matter which way around it's connected. Slide some sleeving over the fuse and crimp the other wire to the other side of the fuse. Slide your sleeving back so it covers all the exposed bits, then carefully bend the fuse tails until they stop the sleeving from moving and exposing any part of the fuse. Test with a multimeter to make sure you have the two wires connected through the fuse, and now you have your first fuse ready. I used different colour sleeving so I could identify the different temperature fuses after covering them up. The next thing to do is to decide which fuses you're going to use where. With everything heated up to its maximum, I measured the temperatures in different locations around the printer. First off, I decided to use 60-degree fuses on the power supply, the solid-state relay, and the wiring that goes to the heat bed. The most likely wiring fault you're going to get on a 3D printer with a moving bed is the wiring that supplies a high current to the heat bed, as it's constantly being flexed. As we all know, if we've ever bent a piece of metal enough times, eventually it will break. The same happens with the conductors inside the wiring, and unfortunately more so with the cheaper wires that seem to be supplied with a lot of these 3D printers. As individual wire strands break, they leave fewer and fewer strands left for the same current to pass through. This causes these remaining strands to heat up more. Over time, the heat buildup can actually cause the insulation to melt until you have an electrical short. At this stage, unfortunately, fire is pretty inevitable. A thermal fuse actually on the wiring, along with regular inspection, will hopefully prevent my wiring ever getting to this dangerous stage. I then place 100-degree fuses underneath my heat bed and inside the top of my printed enclosure. And then finally, I placed a 240-degree fuse just above the heat block on my hot end, pressed against the heatsink. This area doesn't quite get as hot as the heat block itself, and if it ever does get to 240 degrees C, there's a problem. If you're enjoying any of my content, then why not consider supporting the channel by clicking the Buy Me a Coffee link down in the description. Don't worry, you don't have to buy me anything, just click follow and you can see what I'm up to next. One of my favourite features about the Buy Me a Coffee site is where you can leave messages. They might be about a project that's helped you or a video you've liked. I received these two comments recently about my filament dry box video. Jay said he loved the filament dry box and it saved him loads on buying a powered heater. And Yevgeny said, my dry filament thanks you. If you haven't seen the filament dry box video that these comments relate to, then have a look on my channel, or at the end of the video, come back here and click this link. Thanks guys. Now we've placed all of our fuses, we need to connect them all up in series so that we're left with just two wires that we can connect up with our 5-volt supply and our power relay, just as we did on the bench. I use these terminal blocks to keep everything nice and tidy and easy to understand. If you currently use a Raspberry Pi and Octoprint, you can actually do away with the phone charger completely and just take either 5 volts or 3.5 volts directly from your Raspberry Pi board and supply the circuit with that voltage instead. With a simple PSU plugin for Octoprint, you can actually use this same circuit and power relay to turn your whole printer on and off remotely. Let me know in the comments below if you'd like to see how to do this and I'll make a video on it. So now we have everything installed, we better test it. For this test, I'm going to replace the hot end fuse with a 60-degree fuse just for demonstration purposes, but all you actually need to do is unplug your fuse to test that it's working. If for some reason you can't get your relay to activate, then you've either got a blown fuse or a bad connection somewhere. Take your time and make sure every fuse is connected and that all your connections are good. Once you have everything working, your overheat safety circuit is now complete. However, this doesn't now mean that you can leave your printer unattended. All you have now is an extra layer of safety protecting your 3D printer, home and family. If you blow a thermal fuse, please don't just put in a higher temperature fuse without investigating why that area of the printer has got hotter than you expected it to. This whole system is useless without common sense. Whenever you're using a 3D printer, you should always have a smoke alarm and an automatic fire extinguisher next to your printer, whether you're watching it or not. Remember to like and subscribe, and thanks for watching.